Good afternoon. Today is May 3rd, 2022. It's 4 p.m. Pacific time. And this is a faculty and committee training for topics in the College of Business in the PhD in Business Administration. Dr. Cromer is the professor of doctoral studies, and in the PhD program, we now pretty much require the use of structure equation modeling. SmartPLS and G-Power are some of the things that our students are using more and more. So the purpose of today's session is to share some of our experiences with the students in the PhD program. So as you know, the in the PhD program, we emphasize on quantitative methods. There are three courses on statistics: RES 600, RES 601, RES 603. And after that, RES 610 and RES 620, students pretty much demonstrate what they learned, and they emphasize more on the methods that they will use, and then they take already the qualifying exam 1 and the qualifying exam 2. So there has been lots of changes in the PhD program, and the main purpose was to, one, integrate dissertation work during coursework, and another one is to use more modern tools in statistics. And that is the case with the structure equation modeling. We still have the RES 600 that has a foundation of statistics, but after that, the course content now in the PhD program leads to the use of structural equation modeling. That essentially, as you see the definition here, it's a statistical technique for testing, estimating causal relations using a combination of statistical data and qualitative causal assumptions. So basically, all the other types of analysis that we have been studying in the past are represented, are pretty much special cases of structure equation modeling. So we're using, again, as I was saying, more modern tools. And you see how on the top of these three, I mean, I just like this representation. It was from Dr. Jung, that shows the structure equation modeling on the top. Yes, Dr. Angeles, go ahead.
Yeah, I wanted to add the following, because I know it's been a challenge with some of my students in the past, is as the tools evolved, right? Structural equation modeling is second generation tool. The language has evolved. So
Yeah.
you see a lot of old papers will talk about reliability, but they're not really specifying indicator reliability versus internal consistency reliability. And they're different. And sometimes the students, when they pick a new paper, yeah, it says internal consistency reliability, but they pick an old paper, it doesn't state that, and they get a little bit confused. So it's really important for them to understand that as the new tools have evolved, the language and the terminology in some cases has evolved as well.
Yes, good point. Exactly. And I just want to mention that um, these tools have evolved and have changed things to a lot has to do with computers, right? In the past, we had simpler calculators, and it was difficult to run multiple calculations because the processors were slower, right? And now with faster processing power, computers can do more, and these kind of tools have evolved and have changed, and again, they offer more opportunities for our students to to emphasize on the interpretation of statistics. But you're right, the language is a problem, and I think that is why sometimes it's hard for students to capture everything, and it's easier to confuse things because even the literature uses old terminology, but we are sometimes referring to different things. So yeah, just like in everything, definition of terms is always useful. So yeah, good point. And I just want to encourage everybody. I mean, this is a faculty session. You are all faculty in the doctoral programs. I know some of you are very good at structure equation modeling, SmartPLS, because some of you already used these tools in your own dissertations. Some of us, on the other hand, from previous previous dissertations used the traditional statistical tools rather than the SEM. So please feel free to jump in with your comments and again sharing your experiences. So again, I was saying that that our students start with this studying structure equation modeling in RES 603. You know, after they looked at basic statistics and regression, and then they move in RES 603 more with that. And we emphasize more on SmartPLS, but I just want to tell you that Amos is also allowed. I think we recently had one student who still used Amos, and I know some of you did as well. So this is just a traditional comparison between within structure equation modeling, we have the covariance-based SEM and the variance-based SEM. And in the example, the covariance-based is Amos and Liz-Rel. I know Dr. Angolano, you used Liz-Rel, I remember that. And maybe somebody else, but you see, we had even students who used Liz-Rel in the past. But again, now we're moving more to SmartPLS. And the advantages, of course, is that the SmartPLS is does not require large sample sizes, and it allows to test complex models, to assess complex models. And then, so therefore, it's very good for exploratory studies. And most of our students now have complex models, which again, using SmartPLS is very appropriate. Also, we don't, with SmartPLS, can run with a small sample size, but well, we still require the 200, right? And non-normally distributed data, which again, it's another advantage. Now, there are lots of controversies between, you know, which one should be used, and in terms of building theory, probably Amos is more appropriate, but again, we are not stopping students to use covariance-based SEM. They can still do it. It's just like in the DBA also, we don't stop the students to include an additional quantitative method or secondary data. But it really depends on the background all the students have, and also what kind of study they are doing, right? If they are doing even something more than it's the traditional. So that's why we established these minimum requirements, but it's important to know that we can always encourage students to do even more. Dr. Angeles, please go ahead.
Yeah, so I have a personal opinion too, that a lot of times the constructs themselves will drive which model, which tool to use. For example, if they're using transformational leadership, which is a second order construct, you need a tool that can support second order constructs. And so if I'm not exactly sure if Amos or Lizrel can do second orders. I know definitely SmartPLS can. So that's another factor, especially in today's world where second order constructs are becoming more prevalent.
Yeah, good point. And yes, there are more advantages. So that's another one. So in terms of SmartPLS itself, again, that's also, as it's evolving the software, you know, we are in version 3, it's easier to use, and it has more tools that in the past we didn't have. Just like, for example, we wouldn't see the p-value. You kind of had to translate uh, from the values that you obtained to the p-value, or you didn't have the measurement model. I mean, we even, I know with Dr. Cromer, we saw some options that can still be improved to facilitate the view, you know, how you see the results. But now SmartPLS makes more calculations. So with one software, you can do more, whereas in the past, you kind of had to use SPSS first to do the measurement, to analyze the measurement model, and to do more tests. But now SmartPLS has more and more options, and pretty much one student could do all the analysis with one software. So again, that evolution is what is changing. So we can't stay with the past, and we're moving with that software as well. So there, here we have more advantages of SmartPLS, but I just wanted to emphasize that we that the SmartPLS is one tool that can just it's like a blender, right? So you just put everything together and then you can see the results. And the nice thing is that many students now can also even run post hoc analysis easily. That means, if the model didn't run the way they expected, they can change variables and move things and test it again, because again, it's just easy to do it. Now it is we're also emphasizing on the interpretation of results with our students. It's like, okay, now you have this example to run the tools and describe what you found, describe what other researchers have found, and things like that. So I today, Dr. Cromer is going to give us a short demo of SmartPLS and also the G-Power, because again, that's something that now all of our students run. In the past, if you recall, you had to go to statistics book and look at the last page, and you look for the many things had to be done manually. Now these tools are again making it easier. And again, Dr. Cromer, you want to go ahead, please, with your demo, and thank you.
Okay, let me share my screen here. And okay, before we start the demo, I wanted to show something that will probably save us some time. This is the latest iteration of the prospectus template or the proposal template. They both say the same thing in this section. But if you go down to the statistical analysis section, and after it tells just a brief description of what's in there, it says, for example. And so what comes after this is an example of what this section should look like if a student's using SmartPLS. If they're using a different tool, then it would need to match that tool. But it walks through each step that you would need to plan to do. And then what I wanted to show you was this table. We built a table that shows the acceptable values for all the tests that you'll be doing, first in the measurement model, then in the structural model. And so I'll be using these same metrics as we go through the demo. But this is, you can go to the templates for the proposal or the prospectus, and those are right there so you can look at it. Also, one other thing that me and Dr. Ansley was talking about before, this first one, unidimensionality and indicator reliability. For most of our students, they're the same thing because they're using scales that are proved reliable and valid in other settings. But in both of those things, when it talks about unidimensionality, it's making sure that the factors loading are all loading on the same construct. If you remember back in your SPSS usages, when you run factor analysis, if you don't constrain the number of factors, if a factor has multiple dimensions, then it'll load across those factors, and there'll be several factors identified. We don't have that in SmartPLS exactly like that. So what you want to do, let's say if you run your unidimensionality and only a third of the factors load, then most likely there's other dimensions underlying that you need to play around and try to identify. If there are multiple dimensions, you need to try to break that out, and you do that kind of just by experimentation is the way you do it in factor loading. But I wanted to mention that. And then everything else we're going to go through in our model testing. This is the model we're going to test. And there's 6 hypotheses. The first hypothesis is that abusive leadership is negatively related to organizational commitment, and that's here. The second is that abusive leadership is negatively related to organizational citizenship behavior, that's here. The third is that organizational commitment is positively related to organizational citizenship behavior, that's here. The fourth is that organizational commitment mediates that relationship between abusive leadership and organizational commitment, and that's represented by the dotted indirect relationship line here. The fifth one is that the degree of assimilation moderates the relationship between abusive leadership and organizational commitment. And then the last one is that there's a difference in the reaction of males and females to abusive leadership, and we'll test for that using multi-group analysis. Now, the first thing our students are going to know if they've developed this model is what size sample do they need. And so G-power analysis is the best way to test that. And first, you'll want to change t-test to f-test, and it gives this in the instructions that you'll find in the resources for students sections tells how to do this. But you go to the f-test, switch your statistical test down to linear multiple regression, fixed model, R-squared deviation from 0. That's the test you want to run. You see here in this model, we have, this is a second order construct, so it's not a measured variable. So we have fear, intimidation, degree of assimilation, and organizational commitment. Those are our 4 predictor variables, all predicting organizational citizenship behavior. So down here in the number of predictors, we're going to change that to 4. Else is where we want it. We want a 95% power, we want a 5% eligible probability, and we want a 0.15 to effect size. Does somebody say something just then? I'm sorry. Okay. All right. And then just run calculate. And that tells us that the minimum sample we need for this type test is 129. So the minimum that we allow for the program is 200. So what you want is you want the larger of this G-power minimum, R200. Another tool you want to use is this XY plot for range of values. If you just click that XY plot, display markers, and drop it down to 0 on the number of digits that it shows, and click draw plot. And here's a good example that you can use to see that for a given sample size, for 95% power, 129 is where that hits at. So both of these are good to use, and what most of my students do is take these both, copy them, put them down in an appendix, and then reference them in the sample size. Okay, so that's G-power. It's pretty easy to use. So let's go into the model. I've already, in SmartPLS, in the interest of time, I went to a new project, and then I named the new project Faculty Training 5322. And then once I named it that, then it'll come up and it shows this, and it tells you to double click to load the data set. I double clicked and loaded the data set. These are the indicators in the data set here. But if you go to this tab, it gives you all the indicators, all the descriptives for the indicators, which an indicator is a question like F1, the first question on the fear scale. This is it for that. What it doesn't give you, and then the raw files here, and it's in a common eliminated format. But what it does, and these are the correlations between indicators. You don't really use a lot of this, but one of the things I wanted to point out, you can, because when if you go to the latent variable descriptives, and I'll show you that in a little bit, it doesn't give you, it zeroes all the variables, so the mean on everything is 0. The only place the mean is not zeroed is here on this screen. What you can do is you can copy this to a clipboard, paste it into Excel, and then like on the F scale, like if we used all the indicators on the F scale, then you could just take the average of these 5 indicators if we kept all the indicators, and that would give you the descriptives of the latent variables in the format that we want them at. Or you could just load them up into SPSS and do it. Go ahead, Dr. Guzman.
I just wanted to emphasize, to mention that this is what we wish SmartPLS had, but doesn't yet.
Yep.
Right?
Yeah,
but again, there are some things that I wouldn't be surprised that in a few months they will have it also.
Right. Okay, so let's go into the model. I've already indicated I didn't include anything. I wanted to show you how to do it. So I've loaded in our model everything except the last construct. So if I click latent variable up here, and I stick that construct right there, then I'm going to go back to select, and I'm going to right click and rename that, and I'm going to name it intimidation. All right, and that's it. And then The next thing I'm going to do is put my connection in there. These are both reflective indicators of abusive leadership. So I just put that line there. Just click on this one, bring it here with the connection, and connect that line. And then let's make it look a little more even. All right, now what I need to do is I need to include my indicators. So since that's intimidation, come over to this side. Those are the 5 indicator indicators of intimidation. So I'll bring those out there, and now it's there. If I didn't want them there, let's say I wanted them beneath, all I have to do is go from the select and select it, and over here you can see I can put it wherever I want it at. I can move them around. You can manipulate it, but over here is fine. Okay. For degree of assimilation, when you want to do moderate as a moderator, you do it a little differently in here than you do in a diagram. The first thing you have to do is you have to connect the moderator to the dependent variable of what's being moderated. And then you come up to moderating effect, and click the construct you want to moderate. You click the moderator, which in this case, degree of assimilation is the moderator, and the independent variable is abusive leadership. And I click OK, and it shows up. Didn't show up right. Maybe because I hadn't finished loading it here. I'm going to do that again in a second. Let me load these indicators, and then maybe that'll pop up. Okay, so when you're doing a second order construct, this is a second order construct here, then the way we do that is you load all the indicators for the dimensional constructs. Okay, so I want to come back and take all the indicators from F1 to I5, all the fear indicators, all those, and I'm going to drag those and make those also indicators of abusive leadership. And then I'm going to right click, hide those indicators. Okay, got to remember they're there, because if we make any changes, we have to change it there also. Let me try that moderating effect again and see if I can get it to show this time. Okay, degree of assimilation, abusive leadership. Okay, and now here it is. So this is the moderating effect. And if you want to move it around, like I'm going to take this and I'm just going to bring it up here to put it out of the way. But what that moderating effect is degree of assimilation moderating this relationship between abusive leadership and organizational commitment. That's how you set it up. Okay, so now let's run our measurement model. In the measurement model, what we're wanting to do is validate our measures. So we want to make sure that these 5 indicators are valid and reliable measures of this construct fear, and the same thing for all the rest of them. Now, you notice degree of assimilation, assimilation only has one indicator, so there's no validation to be done there. It's just a single item measure. All right, so we go to calculate, and we'll run the PLS algorithm. You could also run the consistent PLS algorithm. I usually just run the PLS algorithm. And you want to change it to factor analysis, and I usually bring this number up to about 2,000, just so it has more iterations, gives you a little bit better accuracy. And then we're just going to start that calculation, and it runs pretty quick. Okay, so now it's finished. And you're in this section up here at the top. This is your figure, and this is where your report's at with all your tables. So I want to look at the figure first, but then I'm also going to show it to you in the tables. So if I go to the figure down here on the calculation results, this lets me pick what's displayed in the image. What I want is on the inner model, I want it blank, because I don't care about that with the measurement model. I only care about the outer model. On the outer model, what I want is the loading, so that's good. On the constructs, I don't want R square. What I want there is AVE. All right, and the reason I want the AVE is because of the metrics. An indicator is good if it's above 0.7, it's a good indicator. If it's between a 0.4 and a 0.7, it's still a good indicator as long as my AVE is above 0.5. All right. because that means it's got good convergent validity. So when I look at my indicators, I'm going to show you two ways to do it. I want to look here. So if I look at these indicators, these are factor loadings, is what they are. You see F5, it loads very low, negative 0.2. All right, so it's not loading with the rest of them. So I'm going to just delete that one. I'm just going to make it go away because it doesn't load, just like I would in any factor analysis. Let's look at the rest of them. On these, they're all up in the 0.9s. They load very highly, strong AVE, 0.9. Organizational citizenship behavior, everything loads very well. AVE is a 0.82, so that's really good. If I go to organizational commitment, everything loads above a 0.7. 0.75 is the AVE, that's really good. Doesn't really apply to this because it's a single indicator. So all I need to do is I need to change this one. But before I do that, let's look at the report. And let's go to the outer loadings tab here. If I go to the outer loadings tab, this is a what this is this is a factor analysis is what it does. Now what I see here is I see fear loading here and intimidation loading here. But this is the second order construct. So I'm not really worried about this because it's not a measured variable. But over here on fear, I see all these load fine except for F5. If I go down here to intimidation, all these load strongly. And it's one good thing they turn green. So it makes a red one stands out. If you don't, it makes it harder to miss it. Moderating effect, we're not worried about it. This is organizational citizenship behavior. They all look good. And this is organizational commitment. They all look good. So this is basically just a factor analysis table like you would see in SPSS or anytime you're in exploratory factor analysis. And so let's go back up and let's make our, let's go back to our model. And F5 didn't load, so we're just gonna select it and delete it and run it again. And it saves your settings just like it does in SPSS. Go ahead, Dr. Angelo.
You got to remove it from the second order construct.
I will when I get to that. I'm not there yet.
Oh, okay.
Okay. Okay. So now we're good there. We're good there. All right. So this is a good measure of fear. This is a good measure of intimidation, good measure of organizational commitment, good measure of organizational citizenship behavior. So those things are good. Now the next thing we want to do is let's go into abusive leadership because it's our second order construct. Let's right click it and let's show the indicators again. All right. And make sure it matches. 1 through 4 is good. F5 is gone. 1 through 5 is good. So we're good there. And so let's hide those again. Okay. And let's run it one more time because all our numbers went away when I did that. And let's finish looking at our measurement model. Okay, we did our factor analysis. Our outer weights are good. Now we want to look at the construct reliability and validity. This is the second order construct. We're not really worried about that. We're worried about the measured constructs. So let me make this bigger. So degree of assimilation, it only had one indicator, so it's going to be a 1. I'm not really concerned about it. We're in the moderating effect. We're concerned about fear, intimidation, OCB, and organizational commitment. Now, Chromebox Alpha and composite reliability, these are the two that we're looking at. And of the two, composite reliability is the more important. So let's say if the organizational commitment was a little low, but the composite reliability was good, that's okay. Composite reliability is more important in partial least squares. But you can see they're all above 0.7, and 0.7 is the cutoff, just like it is in SPSS for reliability. So this is our composite reliability. Average variance extracted, we want that to be above a 0.5, and that's how we measure our convergent validity. And it's above a 0.5, so we're good there. The next thing we want to look at is our discriminant validity. Okay, and we're going to look at two different ways. We're going to look at the Fornell-Larker criteria, and what we want to know there is that our if we go across the top line, still just looking at the measured variables, bring this out so it looks a little bit better. And what you want to make sure is that the AVE is larger than the squared correlations below it, and we don't have any issues there. if you look, you'll see that fear and intimidation are a little close, but not much, so it's fine. If I go to the HTMT, all right, what I'm looking at HTMT is I'm looking to see if there are issues with multicollinearity. So you see fear and intimidation, they are really close, like 0.9s. If you got something above a 0.9, it could be an issue. And organizational citizenship behavior, these are all close to abusive leadership. Now, if you remember, abusive leadership is a second order construct. And what is it made up of? Where its dimensions are fear and intimidation. So yeah, it should be. If I go over here with fear, I see that fear is highly correlated with both of these. And I see the organizational citizenship behavior, these are highly correlated. And so that could be an issue. So what I want to do is go to the VIF, go to the variance inflation factors, and let's see where we're at. And we can see that, yeah, down here, some of these are pretty high. So we do have some multicollinearity issues on these indicators. And I'm not that worried about it in this one because I wanted to show you how to do a second order construct. So I took a single scale and broke it in half. And so I would expect high correlation because they are both in the same scales. So I'm not as worried, but usually if you had two indicators that were higher than 10, 10 is usually a good cut. If it's higher than a 10, then you've got some collinearity issues and you might want to look and make sure that you're not actually measuring the same thing there. But those are the VIF values, and that's where you can check that at. If you go to discriminant validity and you see that there are some issues, then you can go check the VIFs, and you really want everything that in a conservative view, you'd want it below 0.5. In a more liberal view, you want it below 10. But in any case, these intimidation things are a little high and a little over the limit, and that's because I'm planning them that way. I took them out of the same scale. Okay. And I think that's everything that I'm concerned about down here for now. Okay, so once we do all that, we've got our measurement model is done. Everything's good in our measurement model. Now we're going to go and run our structural model. So we're going to come back to here, all right, and we're going to go down to bootstrapping. I want to complete bootstrap. I'm going to jack it up to a couple thousand. And I want to change to path analysis. Then we just start our calculation and let it run. This runs a little slow, so it'll take just a minute to finish running. But the good thing about bootstrapping is like when you're working with SPSS and multiple regression, you have to test each relationship one at a time separately and then slowly go through the model. This takes a second to run, but when it's finished running, you've tested everything. You just have to look at your results. And so it's really a neat tool. Okay, so now we're back. So let's go to take a quick look at our model. And let's look over here. What do we want in it? Well, in the inner model, what I want is path coefficients and p-values. All right. You have several options. You can show p-values, t-values. You can show path coefficients with p-values or path coefficients with t-values. What we use in all of ours is p-values, the path coefficients and the p-values. On the outer model, I want it blank. On the constructs, I want to see the r squared. Another thing I do when I'm coming in here is I will go ahead and you can right click on the image, all right, and just, well, hang on a minute. Right click on the image and hide indicators of all constructs. And I usually just make those go away because I don't care about the indicators anymore. I'm on the inner model now with the structural model. And move this up a little bit where I can read it. Okay, so let's look at our effects. First, let's look at our moderating effect. Our path coefficient is 0.098. Our p-value is 0.03, so it's less than 0.05. So if I look at our hypothesis, that abusive leadership, that a degree of assimilation moderates the relationship between abusive leadership and organizational commitment, I have a positive effect there. And I want to run one more test, and I'm not going to do it yet. I'm going to do it in a minute because there's another table that you need to use with that in your reporting. So let's look at our report. And we're going to start with, I usually start with total effects because of my bivariate relationships. The total effects tells you the total effect. If I've got a relationship, let's say between abusive leadership and organizational citizenship behavior, and I go to path coefficient, that's going to give me what I would consider to be the mediated effect. What I want to really know from my bivariates is I want to know without any mediation, I want to know the direct effect. And so I go to the total effects for that. So our direct effect hypotheses, this column, original sample, this is the beta, this is the p-value. So our first, and this shows everywhere there's an arrow, so it's showing relationships from the second order construct back to the first order construct. We're not really concerned about that. So abusive leadership to organizational commitment was H1, and that is significant. P-value is 0.00. From the H2 was abusive leadership to organizational citizenship behavior. That's significant, less than 0.001. Both of those, they're both negative. So those hypotheses are supported. My third hypothesis was that organizational commitment was positively related to organizational citizenship behavior. My path coefficient is positive, less than 0.001. So H3 is supported. Those were my bivariate relationships. And let's look at the moderating effect. Now you see here it shows two examples for that. Our actual moderation effect was from organizational commitment, was on organizational commitment from abusive leadership, and that's a 0.039. You see it's also showing that on organizational citizenship behavior, and that's because there's a path here. There's a path from here to here also affects here. So it's giving you the effect of that moderation on this dependent variable as well as this one. But this is the one that we're testing, is this line right here. So that's the only output we're concerned about there. And that tells us that that's good. Okay, now let's look at our mediation effect. Our hypothesis was that abusive leadership, or the organizational commitment, mediates the relationship between abusive leadership and organizational citizenship behavior. So where do we see that at? If we go to the specific indirect effects, all right, and this is the one I want, abusive leadership, that an organizational commitment mediates the relationship between abusive leadership and organizational citizenship behavior. I have a negative effect, and the p-value is less than 0.001. Thought the effect size and path coefficient different measures. Okay, I'll talk about that. Well, there are different measures. You infer one and you do the other, but we'll get to that. Okay, so the p-value here shows that we have significant mediation. Now the question would become, and there's different schools of thought on this. Some people only concerned are there is there mediation, and here we see there is mediation. The other question is that mediation full or partial? So let's go back to our model here, and we see that this relationship here is still significant. So let's go to our in our run. If we look at the path coefficient table, all right, and we look at the relationship between abusive leadership and organizational citizenship behavior, we see there's a negative 0.432, and it's a significant relationship. If we go to the total effect, that was the mediated relationship between abusive leadership and citizenship behavior. We have a negative 7.95, and it's significant. So we still have a significant relationship. It's just half the size in the mediated than in the unmediated. and that tells us we have partial mediation. Now, if I looked at this path coefficient and I looked at the relationship between abusive leadership and organizational citizenship behavior, and it was no longer significant, that would be full mediation. And that's basically just the Barron and Kinney method. It's just applied in partial squares instead of in regression analysis. Okay. Once I've looked at that, if I look at the R-square report, all right, this just tells me our R-squared for each of the dependent variables. If we go up into the model here, I've actually got it to where it shows us that. So the difference between this and the other is if I'm using SPSS, I'm seeing the R-squared for a specific relationship. What I'm seeing in the structural equation model, and I'm seeing the net effect of all the variables put together. So when I see that this says 72%, 0.717, 72% of the variance of organizational commitment is explained by variance in abusive leadership and degrees of assimilation. Organizational citizenship behavior, 86 of the variance in this organizational citizenship behavior is explained by variance in organizational commitment and abusive leadership. So I'm seeing a net effect on the variance instead of a specific effect from each line like I would in a traditional model. Okay. Any questions about this before I do the next test? Because all this goes away when I do the next test. Nothing? Okay. Hopefully it's because I'm explaining it well. Go ahead.
I think just to remind everyone that this session is recorded, and of course the students are the ones who should be running the tests, but you want to know what to ask and what are the things that they should include. Again, the template now in the PhD program, our dissertation template has headings and subheadings that guide of about what should be included, but it doesn't have like everything because it really depends on the model and so on. So that's the reason of this training, to again see what the students should be running and how again the software has evolved, because you can see so many options that we didn't have before.
Mm-hmm.
Yeah.
Okay, there's two more things I need to show real quick here. If I go to the F square, all right, what F square tells us is these over here. This tells us the change in variance explained if I deleted the relationship from the model, and you can see that that if I delete the moderation effect, then that goes away. But everything else is pretty significant to the model. And you can have an X squared, you can do an effect size there, but usually your effect size is going to run with the path coefficient. So a range of path coefficient tells you whether you have a small effect, a medium effect, a large effect in the and here with the path coefficient, the effect size there, small is less than 0.02, greater than 0.02, but less than 0.15. If it's between a 1.5 and a 0.35 is medium, greater than 0.35 is a large. So your effect size kind of tells you that. Your explained variance also has a measure, be it substantial, moderate, or weak. And all of ours were substantial. They were all higher than 0.67. And so, but that's in the template. Okay. So now let's look at what I want to do is I want to run, I want to go back to the algorithm and look at the simple slope analysis. And I want to use that to explain that moderating effect. And what this tells us is for a given level of organizational commitment, all right, then what would our abusive leadership, where is that at? So I can see that this is different. It kind of crosses here. But with the degree of assimilation, for a given measure of assimilation, somebody who's more assimilated, all right, is going to have a higher a level of commitment for a given level of abusive leadership is going to be higher with a higher degree of assimilation than with a lower degree of assimilation. All right. And then this is the mean. So this kind of lets you see graphically that moderation, what's happening there. So overall, there's a negative relationship, the downward slope. But as the abusive leadership gets higher, the level of commitment makes a difference in the effect that it has there. Okay. So let's go back to our bootstrapping run. And what I want to do next is something called blindfolding. And so we're just going to take the same one and we're going to run it as blindfolding and start calculation. And this is a very easy thing to look at because we're only looking at one number in this report. And that's our Q squared. So if I go to the Q squared column right here, what this gives me is the Q squared for each variable with an arrow pointed to it, each dependent variable. These two, fear and intimidation, those are dimensions. We're not worried about those. It's these two dependent variables we're worried at. We want it to be above 0. That's the only thing. They're both greater than 0. And what that tells us is that the model as a whole has predictive relevance, and that it's a good fit model. And that's all you want to see there. The next thing we're going to do is we want to do the multi-group analysis. Now, what the multi-group analysis does is it compares everything in the model to see if there's a difference by the grouping variables. So the first thing you have to do is go here, and you're going to add data groups. And we're going to add 2 data groups. The group name first we're going to add is male. All right. And where we're going to find that at is we're going to go to gender is equal to 1. We're going to add that term. All right. And now I think I didn't do that right. Male, gender is equal to 1, 1. Okay. And now I'm going to add another data group, which is female. And that's gender is equal to 2. Okay. All right. Now I'm going to go back to my model. And what I want to do is I want to do a multi-group analysis. And group A is male, group B is female, path analysis, we're good. Okay, so we'll start the calculation. And now it's running the multi-group analysis. And this takes a second to run, but what it's doing is it's looking at the path coefficients for each group and then comparing the two together to see if differences between them are significant or not. And it's the more grouping variables you have, the longer this takes to run and the more memory it takes to run. And so if you get up to where you've got a lot of grouping variables and try to run it, it could lock your computer up because it just uses all the processor. So I usually try to limit it to maybe 4. It also gets a little bit hard to look at when you have a lot of them because it won't all fit on the screen at one time. But this is almost there. And this is also very easy to interpret. It takes much longer to run than it does to read. And while we're waiting, if anybody has any questions, it's probably a good time because it's taking its time running.
Or comments from those who used a previous version, maybe? Questions or comments?
Here we
Oh, there
go.
it is.
Okay. So what we're looking at, let's go to the parametric test first. No, let's don't go there. Let's go to the bootstrapping results first. Okay. So you see here, what I have here is the path coefficients for female. I have the path coefficients for male. And so let's go to the abusive leadership to organizational citizenship behavior. I see that the path coefficient for the female was a negative 0.365. The path coefficient for the male was a negative 0.407. And if I wanted to look over here, I can see that those were both significant. But that's not really what I'm interested in. I'm just showing you that because you can see if you look at the PLS chart that what I'm looking at now is the difference, male minus female. All right, so on this relationship, abusive leadership is related to organizational citizenship behavior. The difference is a negative 0.042. All right, and that difference is not significant. If it was less than 0.05, this would turn green and I would see a path coefficient. And this is the p-value, male versus female. All right. So what I'm looking in the multi-group analysis I'm looking for statistical significance of the difference between the two. And as you can see here, none of these are significant. So we have no significant differences. So it's not. So let's say if my hypothesis is not supported because there are no significant differences, but let's say if I thought that males would react much more strongly to abusive leadership than females, all right? If that was true, then I would see that abusive leadership on organizational citizenship behavior, let's say, would be a very significant difference, that they did act significantly different. But that's what multi-group analysis is telling you. All you really care about is what is the difference and is that difference significant? And what it's looking at, as you can see, is it's looking at every line, every relationship in the model. It's looking to see, is there a difference by gender? And that's multi-group analysis. And that was the last test. So what we just did was we took a model and we went from nothing and went through all the tests that you would need to do in a normal dissertation with second order constructs, with moderation, and with mediation. So it's pretty easy to run. It's pretty quick to do. It takes a while to get a level of comfort with working with it, so you don't have to keep looking back. And I'm the same way. Sometimes I'll say, "No, how did I do that?" Multi-group analysis is the one that I keep forgetting how to set up the groups in. But there's lots of videos out there available to help. And I'm available also if you start playing with this and you get lost and you're not sure how to do something. I'd be more than happy to do an individual session and walk through it with you or you and the student to try to clear up any confusion they're having. But it's just a really neat tool and it's easy to use. So if you have questions and you don't know you have questions yet, or if you have questions and you don't want to ask them in front of everybody else, reach out to me. I'm more than happy to work with you. And that ends the demo, Dr. Guzman.
Excellent. Thank you so much, Dr. Cromer. Dr. Vivio, please go ahead.
Hi, how are you? Is this something that like on mine, I had to get the license for it when I was doing this. Are the students have this now as part of the curriculum? Do they have access to this?
What most of them do is they use the free version because there's two things there. One of them is there's a free version that's a student version. The problem with that one is it limits you to 100 cases or fewer than 100 cases. So the data set that we use in Research 603, where they learn how to use this, it's got 99 cases in it. And so most of them use that student version there. When they get ready to run their data set, most of them use the free trial, which is a fully functional copy for their free trial. But you can also lease it. You can license it by the month now, and it's pretty reasonable. I want to say it's $20-something, $30-something for a month. Mm-hmm. And so some of them license them also.
Yeah, because what you were saying, there are like subtle changes through this that that I noticed, and so I was gonna probably go through this again and just see what I bought the third edition of the book, but like I said, this would be a good exercise to go through for me to kind of see where the differences happened and play around with the data. That's great.
And I'm glad you said that. That's one of the reasons we went to a standard in the on this
Yeah,
Template.
like
table.
that.
Because
Yeah,
when you read, you have almost every author, it seems like, uses a different value for acceptance. And so what I did was I went mostly with the ones that develop Smart PLS
yeah.
use. And the name just left me just that fast, but it's the
Hair.
same one
There.
that did the book. But
Yeah.
so I used those, but that way we had some kind of standard because it was confusing to the students when they saw this metric here and this metric here and this metric over there.
Right.
Just
Exactly.
went
I
to one
remember.
standard. Yeah. So this is the
Yeah.
one standard so they all can have one thing to go by.
Yeah. This is great.
Mhm.
Okay. Thank you.
Okay.
Yeah, and
Hare and Ringel, that was that was the ones that I was talking about. I couldn't
yeah,
remember their names when I was talking.
Right. Yeah.
Anybody else or Dr. Guzman?
no, I think it was excellent. I just wanted to mention it's 24 euros, right? So in dollars, about $30 a month. But um, we're trying to get more licenses for faculty right now. Only the faculty who teach the class, like IS 603, have the Smart PLS. But definitely, this is something that it's getting into the budget again. Now they have more options with the Smart PLS, which is great, and they have the academic price, which is again lower. But so far, students know that they have to purchase when they are working on the dissertation. So when they are doing coursework, they just use the free license. But when they are working on the dissertation, they purchase the license. It's also the same in the DBA, where they know that I mean, it's listed in the things that they will have to purchase when they are doing their final research.
Yeah. And it was reasonable. It was a reasonable price.
Mm-hmm. Mm-hmm. Yeah.
All right.
Alberto here. I don't know if you can hear me. I
Yeah,
don't
we
have any
can hear you.
questions. I just want to thank you for a wonderful refresher. Um, really comes in handy. Thank you so much.
You're welcome. Glad to be of help.
Yeah, I agree. It's really good.
Yeah, I don't want you to mistake silence for something else. This was really, really good. Interestingly enough, I don't remember the templates that we were given as students being quite so helpful as the ones that we're providing now. I'm very
You're right.
impressed.
Things have changed, and we are really, that is now the trend. Both templates, both handbooks are now so much detail and so much customized to what we are using in both programs. So you're right. I mean, we wish we had these things when we were working on our research,
Yeah,
right? Things have changed so much, but yeah, it's just great. The things that we have now are great, and Dr. Cromer has been working a lot on this PhD template. So, yeah. Any additional comment or question? No? Okay, well, I'll stop the recording now, because you know that if we don't stop the recording, then it won't record. So there. Thank you.